Let's say you don't have to write this down. This is kind of a good little review here. So if I had this. Okay. Is that a relation? No? Sure it is. Yeah. Is it a function? Really? Yeah. Okay. What's the domain? Okay, how would that? So -1, 2, and 3, -1, -2, -3 with just that? With the braces. Okay. And then, of course, you could find the range the same way. Okay. So if I said this, relation? Yes, they all are. Okay. Function? No, because the one happens twice. What's the range? Right? 10, 20, 30. Embraces it. Second set of values. And of course, we could have done a table too. Something that we haven't really looked at quite a bit or a lot, but we can still do, would be graphs. Okay. Is this a relation? Yes. Okay. What's the domain? Yes, they are, but what specifically are they in here? 1, 2, and 3. And what's the range? 1 and 3. Function? Really? Yeah, sure it is. Domain doesn't appear twice. Okay, so we've been doing questions like this, but what happens when I do that? I mean, it's still a function, it's still a relation. But what's the domain now? What's that? First coordinate minus the second one? No, not quite. Add them all together, multiply them. But remember, I just want to state them. Yeah, I think you were saying something, Natalie. But yes, 1, 2, and 3 are part of it, but isn't every number between 1 and 2 also? And every number between 2 and 3 is also included? How do I write that? What's the next number after 1? I didn't say whole number or counting number. What's the next number after 1? 1.1? I disagree. 1.01. No, I disagree again. 1.001. No, I disagree again. 1.0001. No, 4 zeros then 1. No, 1,000 zeros then 1. What's the first number after 1? It's really, really small after 1. Okay? I mean, how many zeros could I write? I could go on forever. So how do I write that? Well, I can't do this because this means you have to write every single number. But that's impossible. You'd be doing it forever, and you would never finish, ever. And you would have wasted your life. So how do I write that? So somehow it's got to be like from 1 to 3. I've got to use a certain type of notation. What's that? Sorry. That's one of the types. That's one of the types. Well done. Oh, you're not supposed to say that, Emily. Okay, so what we're trying to do here is we're trying to figure out how to write a span of numbers. Okay, a span of numbers represents a continuous flow of numbers starting somewhere and ending somewhere. A discrete set of numbers is what we have been doing up to this point, like 1 and 2 and 3. But now we're going 1, 2, 2, 2, 3. TO, not TWO. There's 3 different ways I can write it. One, you guys have seen before. You did it last year, okay, when we did inequalities. And that's number line notation. 2, you saw some of it. And that was the inequality symbols. We did that towards the end of last year. Okay? This third type is going to be something new to you. So all I want to do with this is go through a whole bunch of different examples. And the first example that we're going to do, how do I write, using notation, every number greater than 5? Well, last year when we did inequalities, we did it like this. So let's say 0 is here. And if 0 is here, then 1, 2, 3, 4, 5. And I want to write everyone greater than, do you remember? Okay, use an arrow. Okay, so which way is the line going to go and where's it going to start? At the 0? But don't I want to show every number greater than 5? Oh, you start at the 5. So you start at the 5 and then what? To the right. But we need something else. A dot. Open or closed? Filled in or hollow? Open. Open means we don't include. It's outside. So this was how we show visually everything greater than 5. If it's greater than or equal to, then we fill in the circle. How did we do that using set or inequality notation? We did this. We're going to let X represent any number. So the numbers that we're writing are greater than 5. How do I write greater than using set notation? Alligator to the left, alligator to the right. What's going on? Alligator to the right? Like so? Other way around? Doesn't the wide part open towards the greater? Yes. So, and then the narrow part opens towards the smaller. Aren't we starting at 5 and going greater? Yeah. So this is greater than. Okay, so that you guys have seen, but not all of them. We're going to show some other ones too. This is new. Interval notation. This is my favorite. They kind of look like coordinates. Okay, what you got to do is you got to write the lowest number in your span and then the comma, the highest number, and then you put certain symbols around it. So what's the lowest number in the span and what's the highest? How low do we go? 5, right? But not including. So 5 is going to be first, comma, the highest. Think big. Infinity. Because what's the biggest number? Yes, your sideways 8. Now, we're either going to put parentheses or brackets around it. We put parentheses around it if we don't want to include it. We put brackets around it if we do want to include it. So remember, I'm not including the 5. I put a parenthesis around. Around infinity symbols are always parentheses. Why? Because infinity is not a number. Infinity is a concept. It represents the largest number. However, we don't know what that is. I know your mind gets a little twisted with it. Okay? But we always put parentheses. And don't confuse this with a coordinate. You're not asking to plot the 0.5 comma infinity, because that would be impossible. Okay, let's look at another example. Equal to 5 or less than 5. So number line notation. How do I do it? Start at the 5. Filled in dot or circle. Arrow to the left. Good. Set notation, that's the inequality symbols. Okay, so we're going to, I want to say, okay, any number x as long as it's less than or equal to 5. Well, exactly as I just said it, right? Any number less than or equal to, 5. For interval notation, what's the lowest number? Really? You can't go lower? It is negative infinity. And what always goes around infinity symbols? A parenthesis. What's the highest number? 5. Do we include it or no? Include it, which means bracket. You guys will find this one, I think, or most of you will find this one the easiest. Okay. Okay. This is a little new to you. All numbers greater than 5, but also less than 7. One, 2, 3, 4, 5, 6, 7. We've got to put the 5 and 7 on our number line. Okay, if they're greater than 5, what do I do? Start at the 5. Open circle, or hollow circle, and then it's going to go to the right. But stop at 7, so I don't need an arrow. So, and what's happening at 7? Do I include it? No, so I put another open circle, but I connect them. So it's going to look like that. What's that, sorry?
I said, so it can only really be 6 and like any sort of like decimal like 5.
Which is an infinite amount of numbers, right? But it has to be bigger than 5, but less than 7. Yeah. Set notation, this is a little different. When you start and stop somewhere, if it doesn't go to infinity or negative infinity, you always have to use 2 inequality signs. And they always go that way. They always point that way. So what we're going to do is we're going to put the number that represents what we're allowing in the middle. We're going to put 2 less than signs on either side, because it's less than, not less than or equal to. And then we're going to put the starting and the stopping on the ends. So it's going to look like that. That's what happens when it starts and stops at numbers. Okay? Because if you think of it, you're kind of reading it backwards and forwards. We're representing numbers that if I read backwards here, greater than 5, but reading forwards now, less than 7. That's why the arrows will always go that way. Finally, interval notation. What's the lowest? 5, comma, what's the highest? And what are the symbols around? Brackets? Parentheses around both, because we don't include both. Okay? Greater than or equal to 5, less than 7. So 0, 1, 2, 3, 4, 5, 6, 7. Very similar to the last question, but not quite. Still going to have circles at 5 and 7. Are they both going to be open? No, the 5 is going to be closed or filled in because I'm including 5 now. But because I'm starting at 5 and going up to, but not including 7, I need a connection between them. Okay. For set notation, because we're starting and stopping at certain numbers, I put the X in the middle. I put the lowest here, the highest here. And because I'm including 5, I have to do less than or equal to here. But because I'm not including 7, I have to put less than there. Who can tell me what the interval notation would look like? Bracket 5, comma. That's right. You're getting the hang of it. This one I think we can do pretty quickly because we've kind of done, it's just almost identical to the previous one, except now we're including 7. Okay, so we would go 0, 5, 7, but both the circles at 5 and 7 would be filled in with a segment connecting them. For the interval notation, it's going to be 2 inequality symbols, 5 on the left, 7 on the right. This time they're both going to be less than or equal to. And then bracket 5, comma 7, bracket this time because we're including the 7. Okay, so you can sort of see the difference, a slight difference in the last 3 examples. What happens if we have 2 spans? Okay. All the numbers that are less than or equal to 5, but also all the numbers that are greater than 7, but less than or equal to 10. So we don't have enough notches here to put 0. So what I'm going to do is I'm going to start 5 here, and then go 6, 7, 8, 9, 10. Because I have to include all those numbers in the diagram. When you have more than one span, just do each one separately and then connect them. So how do I show less than or equal to 5? Arrow to the left. How do I show greater than 7 but less than or equal to 10? Segment. Yeah. Using set notation, okay, we do each one separately and then connect it using a certain word, which I'll talk about in a second. So how would I write everything less than 5? Sorry, everything less than or equal to 5.
Less than or
And how would I write this one?
7,
7 less than x.
less than or
English lesson. What word would I use to connect them? To describe both of them. Exercise in English and logic. I don't, what's that? That's for interval notation. Why not and? You're right. It could be and or it could be or. What's the difference? Or is there? Celeste?
or it's like
Right. Right. So is it possible to have a number that's less than or equal to 5 and in between here? No. You can't. It's impossible. It can't be in 2 spots. No such number exists. So that's why we use or. For interval notation, let's do each one separately and then connect them. So how do I write everything less than or equal to 5 in interval notation? What's the lowest?
negative.
Negative infinity, which means what goes beside it? What? A parenthesis. Comma,
5.
5, bracket. And then for this one, 7 with a yes, comma, 10 with a bracket. And now to connect them, the mathematical notation we use for the word or is a U, which means you're uniting the 2 sets. Okay, so these actually mean the same thing, except we use this symbol in interval notation, we use this word in set notation. Yeah. What's that? Sorry? No, I said we use parentheses with infinity symbols. Because infinity is not a number. Okay? We don't know what that number is, which is why we use a parenthesis. Okay? That's just sort of the way we decided on the notation. Well, I mean, I wasn't part of the decision, but okay, last one. And this is a little weird, except for interval notation. It's not weird. It sort of goes in line with what we've been doing. How do I represent every single number? What do I do on a number line? Every single number. Doesn't start anywhere, doesn't stop anywhere. Yeah, like I could use 0 as a reference point. I don't even have to put a dot there. But it would just look like that. It would just basically be the same as the line here. Yamna, you don't get to answer this until I ask you. How would we show it using set notation? Whoa. in nothing. Okay. No, that's interval notation. We got to use less than or equal to symbol, or less than, greater than.
Just less than or equal to.
But that doesn't make sense. How could you use those?
You put 0 in the middle,
Yeah.
and then you put X on both sides of less than or equal to, and then greater than. Am I right?
Don't write this down.
No.
Fun. I mean, does it make sense?
Yes.
Yeah, it kind of does.
Kind of.
Okay, if you use the inequality symbols, okay, but we actually use a completely different type of notation. We say that X, now you want to try? What do you remember?
Wait, X, what?
How do I represent every single number?
X.
Not equals, but you're on the right track. Not infinity, because we don't use infinity symbols in set notation. You're not going to get it.
Oh, X.
What? What? You're just making stuff up. These actually mean words in math. This means is an element of. An E, a fancy E, a curvy E. And this means all real numbers. What are real numbers? Those are numbers that can be written as fractions or the numbers that can't be written as fractions. It's every single number. So that one you're just going to have to remember. You don't have to put the double bars if you don't. If you put R, you'll still be good. But technically, that's how we write it. And I always just say XE double bar R.
What if that's not my way? What do you mean?
What's your way? The way you what?
Like the X.
No. Okay? So the set notation for every single number is a little weird. But the interval is not. If you think about it, what would it look like? Every single number, what's the lowest number? And we automatically put a parenthesis around. What's the highest? That's what it looks like. That's why I like interval notation. Okay? So yes, the one with set notation, like I said, that one's a little weird. Okay? Eventually, we're going to reach a point. We're going to abandon the number line notation because it's just too hard to draw all the time. And we're going to focus on when we do interval, or when we do domain and range, we're going to use these notations. So this we're not doing until a little further ahead, but think about it now. How would you write the domain now that you know the notation? How do I write from 1 to 3? Well, there's two ways you could write it. So 1, sorry? Good, that's one way. Because it's everything from 1 to 3 and including the ends. What about interval? 1, comma 3, brackets. So either of those would be correct. Brackets mean you do include. Okay, good. Okay, so for Thursday's class, exercise 5.4, please. And then, whoa. And then, like I said, the next step is going to be, we're actually going to look at graphs and start doing these with graphs, domain and range. Because that's a big spot, or that's a big area where we use interval and set notation.
Are you kidding?
Hello, what? Hello? Kidding, what? mean, what